So, first of all, I would like only to mention files that would be necessary to use for today's lecture. So I will open directly SIS. And I would like only to announce that I uploaded, according to previous promise, also computations from previous lectures. So here we have flat OMV, which is a data file together with all computations in JAMOVI for linear regression analysis based on flat data. Then you can also find INET OMV. So this is the computation of logistic regression based on data about internet usage. And you can find also as the last item in the list, Titanic OMV. So it means data that were the first example of logistic regression in our case. So these are, I would say, currently historical data. So it means you can find all computations that were performed during lectures. And for today, we would be, of course, at the beginning still using a presentation which is called Lecture 4.5 Advanced 2022. So in this presentation, we will discuss about logistic regression style, and you can find also new one presentation which is called Lecture 7 LCA Advanced 2022. So these are two presentations and data files for today. So for logistic regression, and I'm not sure if it is present here, so maybe I would need to edit if I can see. We should apply data from library, so I will try to find it and upload it. Sorry for mistake. But then we have three files for latent class analysis, and that's data about mathematical skills in fourth grade, which is called Math for LCA SAV. And you have also two related files. One is Microsoft Excel file, so it means extension XLS, and one is once again data file for SPSS, which is called Motivation IND SAV and Motivation LCA XLS. And I will only upload a new one file about libraries, which is not present here. So give me a minute. So I will only change the screen and upload the file about libraries. I will only try to find it very quickly. Yeah. So it is present here. So I will upload the file into both folders. So it means into a master as well as a bachelor course. But for those of you who are registered to bachelor course, I would like to announce that all files that are present in the course for master degree, they are publicly available, and those that are in the folder for bachelor are only for those who are registered to the course. So if you like to visit all these files without any registration to Student Information System, you can go directly to master version of this course. So here it is, data and library. Oh, like this. Once again, it would be publicly available and the data for multinomial logistic regression. So currently also data about library internet usage should be available for you. And I will also make a copy to bachelor course. So here it is. So That's all about today's data file. So I guess we can close the dialogue for student information system. And I would go back into presentation and I will make some small comments to previous discussion about classical, and I would say the easiest version of logistic regression, which is binary logistic regression. So I will only sum up that if you apply binary logistic regression, you are expecting that your dependent variable has only two categories, and it really doesn't matter what would be codes for these two categories. So you can use coding such as 0, 1, 1, 2, 0, 100. It's not influencing results. And set of independent variables or set of predictors could be variables that are cardinal, or let's call it scales, could be also binary, nominal, or ordinal variables. But if you apply binary, nominal, or ordinal variables, JAMOVI as well as SPSS or JESP will automatically recode these predictors into dummy variables. So that's only a brief repetition of classical binary logistic regression model. And I would like only to make small note about standardized coefficients in binary logistic regression. If we apply binary logistic regression in JAMOVI as well as in SPSS environment, there is no option, sorry for that, to compute analogy to so-called standardized coefficients or beta coefficients from classical linear regression. I hope that you remember that these standardized coefficients should be applied if scales for individual predictors are not comparable, but you would like to compare the impact of individual predictors on dependent variable. So that's the meaning of standardizations for independence. I would say not only in regression models, but generally in statistics, that you would like to compare the influence for individual independent variables or for individual predictors. And if you would like to compute results with standardized coefficients in JAMOVI and SPSS, you have only one option. I know it's maybe slightly demanding, but first step would be that you would need to standardize all your individual independence or all your individual predictors. So first of all, you would compute variables that would be based on subtraction of mean and division by standard deviation. Fortunately, in SPSS, and I guess that nearly the same procedure could be found in JAMOVI, you can go into exploration descriptives, and here we have the dialog for saving, I guess, of standardized variables. I hope it will work also here, but I'm not sure if JAMOVI copied this tendency from SPSS. Fortunately not, so sorry for that. So it was a big expectation, but not fulfilled in JAMOVI. But in SPSS, in dialog for descriptives, there is a sub-dialog for saving standardized variables. For JAMOVI, it would be necessary to provide this computation by data transformations. And then in the next step, if you would prepare such standardized set of independence, you would once again recompute logistic regression. The advantage of JESP in this procedure is that JESP automatically can add standardized results into logistic regressional results without any such pre-computations. So if you would like to get standardized coefficients for individual predictors, maybe that JESP is the best option, as there is direct option in the dialog for logistic regression. So that's only a small discussion about standardized coefficients and how it works in different software packages. And I would like only at the end to sum up a recommendation for publishing of results from binary logistic regression. So first of all, be careful. And if you interpret results for logistic regression, it is necessary to differentiate between logics, odds, and also probabilities. You know from the beginning of the lecture devoted to logistic regression that these are three different phenomena, and it's not possible to mix it, that also scales for these phenomena are totally different. Once again, probability could be from 0 up to 1. Odds or odds ratios are from 0 up to plus infinity, and logics could be from minus infinity till plus infinity. And once again, you should maybe mostly use for the interpretation in logistic regression odds and odds ratios, and these are usually directly available by computed results. The next recommendation for publishing of results in logistic regression is that you must be very careful about categories that are reference categories for comparison. And the problem is not related only to predictors, in which usually some category is omitted as reference category by set of dummies, but this problem is also related to dependent variable, as software packages and SPSS and also JASP and JAMOVI do the same fashion, this comparison that category with the lowest value is the reference category, and the second highest category is compared to this reference level. Usually you can find an output, so it means in SPSS or JAMOVI or JASP or in settings which category is reference category. Okay, the basic output for discussion of logistic regression results, so maybe I can open computation from previous lecture about internet usage to see how it works. So basic output that is usually copied as the whole is this table including coefficients. So if I would like to use results from logistic regression, I would usually copy this table, which is called in JAMOVI model coefficients. In other packages, this is nearly the same. So it means this is the table in which you can find all estimates. So it means estimates in logit units, usually also standard error, then computation of individual testing, which is based on so-called Volt tests. And usually you would also add odds ratio and confidence interval for odds ratio. So this is, I would say, standard output from logistic regression. And then usually it is expected that you would add also some values that are present in different related outputs. So my recommendation is, once again, if I go back, that you should also apply at least likelihood ratio test. So this is the value in JAMOVI, which is present in a separate table. I'm not sure if it is present here in this table, but we can ask for this output. So if I go back into the dialog and I would ask for model fit, so I can ask here for overall model test, and I would get this table in which there is value in chi-square unit, degrees of freedom, and there is p-value. So these three last column of model fit measures table called overall model test. So these are results of likelihood ratio test. In SPSS, you would find it as likelihood ratio test. Once again, it is testing in the same fashion as overall F-test in classical linear regression, whether at least some predictor is influencing dependent variable. So that's about overall test based on likelihood ratio. Then usually we are also displaying so-called pseudo R-squares. So it means analogy to R-squares from linear regression. And there are many of these, at least in JAMOVI or JASP or in SPSS, there are also more than one. And the most common in social sciences is Nagelkerke R-square. So currently here in model fit measure, there is written R-square and superscript N, which is standing for Nagelkerke. So this value would be also usually copied into the output. And recommendation is that it is also good to publish classification table, or at least the percentage of correctly classified cases. If I remember well, it was one of the latest outputs last time. So here we have in JAMOVI, it is called prediction table, but still the same topic. So once again, it is combination of real value of dependent variable that's observed rows in this table and predicted by my model. And here in JAMOVI, there is no overall percentage of correct classification, only by individual rows. There are percentages of correctly classified users and non-users of the internet here. So this table, or at least these percentages, or you can also very simply compute overall correct percentage, should be the last output that should be related to logistic regression, at least in binary logistic regression model. So, and as you expect, I would say that we are finishing one topic. So I can also announce that next 2 weeks are available for you to fulfill homework for binary logistic regression. I will send you details about this homework by email, but at least I can very simply discuss what would be your task. So you should have some dependent variable with 2 categories only. If your variable has more than 2 categories, it is possible also for you to make binary variable from this. So it means to merge some categories. It's quite classical style. We will see this example also today in writing class analysis. And then it would be nice for you to prepare a set of predictors. Some of these should be binary or nominal or ordinal, so it means categorical, and some of these should be also cardinal, as interpretation for these are slightly different. And you should prepare the model, maybe improve the model. You should also try to discuss about all results in binary logistic regression. There is only one point missing in previous discussions, and it is the preparation of probability computation. And I can promise that I will prepare for you some special file based on these data about internet usage, and also some short video that will help you to prepare also these computations for probability and for preparing of some probability curve, so I can add you also some new material for this probability. So that's what is impossible to compute directly in JAMOVI, JASP, or SPSS, but it can be very useful for interpreting results, especially for those people who do not understand two logistic regression models. So it's not necessary for you, as currently you are familiar with these models, but for people that are not understanding logic of regression as a whole, it is much better to prepare some charts that can explain very easily your results. So it would be a recommendation how you can show logistic regression results for those who are totally not capable to understand regression as a whole. So it would be slight magic, I would say, for laymen. So that's all for binary logistic regression model. If you have some questions, feel free to ask me. And in the next step, we will briefly theoretically discuss the model for dependent variable, which is nominal. So it means we will have more than two categories, and then we will skip into the new topic of latent class analysis. So some questions so far? Okay, so if there are no questions, so I would skip to the next slides. And first of all, I would like to mention that you can find two different names for this logistic regression model. One of these names, and I would say maybe slightly more common, is that it is Polytomous logistic regression, and sometimes it is called as multinomial logistic regression. These expressions are only differentiating according whether they are discussing the property of the variable or distribution which is behind the scene. So we can check JAMOVI, and we can find that in regression, you can find for n outcomes logistic regression that in JAMOVI it is called multinomial, but sometimes you can meet also different version, which is Polytomous. So you should know about these two names. So I would close previous dialogues, and before we start to compute real-life results, it will be example quite similar to previous discussion, whether I'm using internet or not. Currently, we will be only combining internet and library usage. So I would like to say something about theoretical background for Polytomous logistic regression. So if my dependent variable is nominal with more than two categories, it means that it would be impossible directly to use one equation that would be modeling probability to be in one category and probability to be in the second category, as there is the third, fourth one, etc., etc. And if you remember the style by which we are preparing dummy variables, so it means that we would take one category as the reference and omit from the computation, and all the rest will be compared to this reference level. So nearly in the same style, we will be currently treating dependent variable in logistic regression. So currently, the same logic as preparation of dummy variables. Usually these dummies are independent, so we will apply for dependent. So what does it mean? If, for example, I would be combining internet and library usage, I can create 4 categories. So it means I am using internet as well as library, one category. I am using only internet but not libraries. The third one would be I'm using only libraries, not the internet. And the last one, I'm not using anything, nor libraries, neither internet. And if I have these 4 categories, I can decide that one of these categories would be a reference, and I can compare usage of internet and library, only internet, to this reference level category. I'm not using anything. So I will prepare from 4 categories, 3 possible comparisons. So this is nearly the same style as you would create from 4 categories, 3 dummy variables, and all these will be comparison of individual categories to the reference level, which is omitted from the computation. And if we are discussing about this model by equations, so I can prepare a brief discussion from these equations. I'm not sure if I save equation from previous lecture, maybe not, so I will type it. So if I would have classical logistic regression, so it's on left-hand side equation, which is starting with logarithm, probability of some category. I would call it, for example, as A, divided by the probability of minus 1 minus probability A. So this would be classical style for logistic regression. And on the right-hand side, there would be some constant or intercept. So I would type only I and t, then the impact of the first variable, so I will type b1 multiplied by x1 plus b2 multiplied by x2, etc., etc. So that's for two categories only. And currently, for example, for our case, we have four categories. So we would apply three comparisons, and I would decide as reference level to apply those people who are not using internet as well as who are not using library. So I would be comparing maybe for the first step those who are using library and the internet. So I would type these as AIL people, and those who are not using anything, and I would type these people as those who are not using internet, not using library, and I and L for simplicity. So this would be the first comparison of probability to use both of these devices and probability that I'm not using anything. And I would get the first equation, and there is only one technical detail that must be somehow differentiated between different equations that will follow. So this will be the first equation. So I would call, for example, this intercept as the first one intercept. So I would type, for example, here intercept number 1. So then I would take B1 with next one I as the first one slope for the first predictor, B1, 2 for the second predictor, etc., to differentiate intercepts and also individual slopes for next equations. So I must find some more indexing that would differentiate results for these different equations. And if I'm currently preparing this first equation, so I can follow next two equations. So I would copy the first one, and I will only slightly change it. So for the second comparison, I would be, for example, comparing those who are using internet, but not using library. So I would type probability of I and L, and reference category are still those who are not using anything. So not internet, not library. And I must slightly change right-hand side. So it would be intercept number 2. So I would type number 2. Here, as you can see, I'm not using classical numbers, but numbers from Roman times. B2 as the second slope for the first predictor, B22 as once again slope for the second predictor, etc., etc. And last one equation would be, once again, logarithm for those who are not using internet, but those who are using library. So NIL I'm typing. Reference category is still the same. So it means, once again, probability for those who are not using anything. And on the right-hand side, I must create the third set of intercept. So intercept number 3, first slope number 3, second slope number 3, and it would be our result 3 equations. So if you understand at least a little bit to these equations, it means that for logistic regression, in which I have 4 categories of dependent variable, I would get not one set of coefficients, so it means intercept and slopes for individual predictors, but I will get for 4 categories 3 sets. So it means that original table for binary logistic regression, that was one table with one set of coefficients, currently will be divided into 3 parts, comparing those who are using internet and library, those who are using internet but not library, and not internet but library. So this will be table which will be merge of 3 original tables based on these 3 equations. So it will be, I would say, small complicated step in Polytomous logistic regression. And I guess that you understand that if you will have, for example, 10 categories of dependent variable, then you would get, for example, 9 set of these coefficients, and it would be quite difficult maybe to interpret results. So you wouldn't be interpreting only one set of coefficients, but many sets of coefficients, and number of these sets is based on number of original categories minus 1. So that's the trick which is behind Polytomous logistic regression. Maybe that currently you can ask yourself why I shouldn't apply set of binary logistic regression only by previous dialogues and by previous computations, and you compare the first to the last category, the second to the last category, and the third to the last category. And that's my question to all of you, whether it would be possible to apply this set of binary logistic regression and to forget about Polytomous logistic regression, or maybe whether there is some reason to apply some special technique for this set of all equations together. Maybe I can give you a small hint, and the situation should be similar to discussion about possibility to apply analysis of variance as a whole or individual sets of t-tests. Maybe that if you remember something about difference between t-test and analysis of variance, it could help you to answer this question. So do you have some proposals why we shouldn't apply set of binary logistic regression and apply this Polytomous logistic regression model? What could be behind the scene? So some proposals, at least for those who are in Zoom, as we are here in very small numbers in classroom. So are you still with me? Do you have some ideas why we shouldn't apply set of binary logistic regression and we should apply the one model for the whole set of all equations together? Okay, so there are no answers, so I can give you the answer once again, which is nearly the same as for comparison of t-tests and analysis of variance. If I would apply individual t-tests instead of one overall analysis of variance, and for example, I would be computing by 0.05 confidence level, so I would be making mistake at 95% level. If I would be applying such two tests with 95% of, I would say, correct conclusion, final correct conclusion would be 0.95 multiplied by 0.95. So it means approximately 0.9. And my mistake wouldn't be 5 in percentages, but 10 in percentages. If I would make 3 such comparisons, it would be mistake approximately 0.15. 15 percentages, etc. So it is increasing and increasing. And in the same logic, it would be present in binary logistic regression. And only if I take all these computations together, I am trying to avoid such mistake, which would be inflation of alpha or p-values. So it means values that are usually used for the evaluation of so-called statistical significance. So that's why we prefer, instead of set of t-tests, to apply ANOVA with some of post-hoc comparisons. And here, if my dependent variable has more than 2 categories, I prefer to apply Polytomous logistic regression. So I would like only to mention some technical details in software packages. So if we would be applying Polytomous logistic regression, it is usually present in software packages. That last category by default would be omitted as the reference category. And if you would like to change it, you must change this option in JAMOVI, in JAMOVI and SPSS it is the same. Next comment is related with software packages capabilities. In JAMOVI and SPSS, you can find this Polytomous logistic regression model. In JASP, it is still not implemented. So for this Polytomous logistic regression, currently SPSS and JAMOVI is available. In JASP, there is no such option. And the same is true also for last one model, but we will not discuss this model in detail. But if you would like also to apply model for ordinal dependent variable, here it is, ordinal outcomes in JAMOVI. In SPSS, you can find ordinal logistic regression model. Once again, in JASP, it's impossible to apply model for ordinal dependent variable. I would like only to mention that for ordinal dependent variable, the style is slightly different. So we are not creating these individual equations, but we have only one equation, and ordinality is only implemented into different so-called thresholds, but we will not go into details. If you are interested in this model, you can consult literature or some other materials available on the internet. So here we are, and we will be using currently data file library SAV. First step would be that we will learn very briefly how we can compute Polytomous logistic regression model in JAMOVI. In the next step, I will show you also the same computation in SPSS for you to see these two packages as active options. So I would briefly skip into JAMOVI, and first of all, it's necessary to open data file library SAV. So I would go into opening icon and I would find data file for libraries. So here it is, and I would mention only that these data are originally from the US, approximately 15 years old, if I remember well, but that's not for us the most important information. And here I would go only through basic variables to have information, what is present in dataset, and then we will try to compute results. So first of all, I would like to mention that somewhere in the middle of dataset, there is a variable which is called group, and that's our dependent variable. If you check options for this variable, maybe I can show you the computation of frequency table. So I will go into exploration, descriptives, ask for groups, and ask for frequency table. So you can find that here we have 4 categories. I am not using anything, neither library only, internet only, and both of these. So here it is. And I would like also to mention, that's why we are mainly publishing this table, that here we can see number of units that are present in individual categories. So you can see that our sample size is quite big one. It is approximately more than 2,500. So that's maybe first nice information. And you can also find that for individual categories, there is quite a lot of people here. At least hundreds. For the last category, there is more than 1,000. And one big warning related to logistic regression as a whole. So it means we are currently discussing about all logistic regression models. If you would like to apply logistic regression, so it should be fulfilled that at least approximately, I would say 50 units should be in every category. So if there would be a small number of units in some of these categories, I would like to warn you against usage of such category in logistic regression. If this condition is not fulfilled, you have, I guess, 2 options. If your variable has more than 2 categories, so you can merge some categories together to increase number of units for individual category, which is quite rare. And the second option would be to omit such category. And of course, if you apply binary logistic regression and you would have data something like, for example, 900 and 5 people in the second category, there is no chance to apply logistic regression as a whole. So there is small warning against small number of units for individual categories. So here, it's not necessary to solve this problem. Our individual categories are not quite rare, but sometimes it can happen. And then once again, you need to solve it. I can say, especially for Czech students, that if you have textbook for data analysis in SPSS, and you would be reading chapters 13 and 14. So especially if I remember well, in chapter 14, which is devoted to Polytomous logistic regression, there is such case with a small number of units in individual categories, and there is also some special warning from SPSS package in these cases. So you should take these recommendations into account. Maybe we are currently discussing about this topic, so it means about sample size. I would like also to mention, I would say, general rule for sample size in regression models as well as for logistic regression models. I'm not sure if we mentioned classical rule for linear regression, but I would say the most often applied classical rule for linear regression is saying following. If you have K would be better, letter K predictors. So you take K plus 1, as there is always intercept present here. And if you multiply by 10, it is a recommendation for minimum value of units for linear regression. So once again, you take number of predictors as K, add 1 more for the intercept, and you multiply by 10, and that's minimal sample size. For logistic regression, these rules can be slightly more complicated, but I would simply say that for the easiest computation, you can apply the same rule as for logistic regression. So at least once again, K plus 1 multiplied by 10 times, it would be minimum sample size. One warning related to currently discussed Polytomous logistic regression. Take into account that here currently for 4 categories, I would be applying 3 different equations. So I must also multiply the sample size by 3 times. So currently I would say K plus 1 multiplied by 3 multiplied by 10, and it would be my final minimum sample size. So that's general recommendation about sample sizes. I would say that these rules are very rough and only approximate. If you would like to compute precisely your minimum sample size for correct computations, though there are some special procedures and also special packages from those who are available without any payment. So it means between freeware packages, the best one is called, I can show you also the icon on my computer. The best one, I hope it's available on my computer. I must find it. Sorry for waiting time. Not sure if it is present on my computer, so sorry for that. So I must try to find it in my memory. What is the name of this freeware package? And I can see it as icon. So maybe give my memory some time, and I will mention the name later. Also in SPSS, there is some small package for computation of sample size, but it's not so capable, at least for logistic regression. It cannot find. Yeah, I remember the name of this freeware. It is G star and power. So G power is freeware for computation of sample sizes. So that's all for this introduction. And I would go back and we would currently apply Polytomous logistic regression for internet and library usage. So I would go back into JAMOVI, and here we know the dialog could be found very easily by regression for Polytomous or multinomial model and outcomes multinomial. And if I open the dialog, I guess this is nearly the same dialog as for binary logistic regression. So that's very easy to guess that dependent variable is variable for our groups. And then you need to differentiate between covariates. So it means independents or predictors that are cardinal, and between factors. So it means independents that are nominal or ordinal, and will be automatically recoded into dummy variables. So I would maybe, for simplicity, start with the introduction of this output table. And you can see that by default, currently, it is including 3 comparisons as I expected. Library only, and I'm not using anything. Internet only and anything, and both, so it means internet and library and anything. So these are 3 comparisons that are prepared for us. If we would like to change reference level, which is currently neither, so I can go into reference level option in this input dialog, and I can change this reference level into other level, which is present here. So that's very simple analogy to binary logistic regression. I would say that maybe this category neither is the best one for comparison, as I would be comparing, I would say, anything with at least something. So from substantive point of view, it seems quite logical. So that's reference level. You can see that also by default, you would get a basic first table, which is somehow evaluating the model fit. And automatically, once again, McFadden pseudo R-square is implemented. So if I would like to find anything else, I can go once again into model fit. I can ask once again, usually in social science, we are applying Nagelkerke R-square. And if I would like to say detailed likelihood ratio test, I can ask for overall model test, and I would get 3 more columns to this table. So currently, classical 2 tables, I would say model fit and model coefficients prepared for us. And we would need to add some computations. But maybe before we start, I would go once again to the next dialog here in the menu, and it is related to model coefficients. And we know that mostly we would ask also for odds ratios and their confidence intervals. So I would ask for odds ratios and confidence intervals, and 3 more columns will be added to model coefficients table. So I guess that currently we are prepared. I must say that implementation of multinomial logistic regression in JAMOVI is still, I would say, at the beginning, as some outputs that will be present, for example, in SPSS are missing here, but at least the implementation is fulfilled. Once again, in chess, there is no such implementation as a whole. So currently, we have all tables prepared for all necessary computations, and we can start to include predictors. First of all, I would propose that we would take some predictor that is cardinal. So first one maybe would be quite good. So it means we would include age as the predictor. So I would take age as covariate. And in a few seconds, I hope so, I can get results. So I will only change the size of these windows. Once again. So maybe not today. Sorry for problems with my touchpad, so I will move the table here if it is necessary. So first of all, we can see that if we included the age as the only one predictor, so it is implemented into the first equation, second equation, and the third equation. So once again, if I go back to these equations, our equations are finishing here after the first predictor, and we have the first one, second one, and the third one set of intercepts and slopes. And here it is the first intercept, first slope, second intercept, second slope, and the last one. So these are results. And as you can see, as the age is increasing the probability to use library, internet, and both of these is decreasing. So that's the first phenomenon. And once again, if we would like to interpret the impact of the age, we would mostly apply result for odds ratio. This is very close to 1. We know that if it is below 1, we would make inverse value, 1 divided 0.99, 1 divided 0.955. And once again, if we would like to use age as the predictor, maybe we wouldn't interpret the change by 1 year increase only, but we would use maybe some generation insight, such as 20, 30 years, or maybe more. So if I would like, for example, for simplicity, to apply internet only and age impact, so I would take this 0.957. So I would use Microsoft Excel for these computations. 0.957. So that's odds ratio. Once again, I would reverse this odds ratio. So it is 1.044. And if I would like to know what would be the change, and currently I am reversing this comparison. So it means I'm comparing those who are not using anything versus using library. So it means that if I'm older, I am more probable not using anything in comparison with library. So for 20 years change, I would take this value and make a power of 20. So I would take this value and power of 20, it is head symbol. So if you take the symbol which is above number 6 on English keyboard, and 20 power. So if you are 20 years older, it is saying your odd, once again, it's not probability, your odd to use anything in comparison to use library is 2.4 higher. So that's for this value. So that's the first computation. I will only change this computation. And if I would like to compare all the rest, so it means, for example, for library as well as for both of these devices, I can change only the first coefficient. For example, both devices 0.955 and odds ratio would be 2.5. If I am 20 years older, the odd, once again, odd is using versus not using, both versus neither currently here would be 2.5 higher. So it means older people, in general, if I sum up all these results, mostly are not using anything, and younger people are using at least some of these devices. It would be my general comment to these results. And maybe before we would go further, the question is whether it is understandable how we would interpret these results. I would say it is direct analogy to binary logistic regression, only we do not have one coefficient, but we have 3 coefficients for different comparisons. Okay, so if there are no questions, we would add some more variables into our model to see how it works. And I would propose currently to take some variables that will be nominal or ordinal. So we would have some dummy variables or at least some binary variable as the predictor. So maybe first of all, I would take the variable work, which is originally designed, if I remember well, 1, somebody who is working, and 0, somebody who is unemployed, I guess. So it is classical binary variable. So it means no dummy will be created. This variable will be automatically applied as it is. So I will take it as factors. And you can see that automatically, as it is defined, lower category is 0 for no, and 1 is for yes. So I'm comparing those who are working with those who are not working. So if I can see, for example, odds ratio for the first equation, so it means comparison library only, and neither is 1.1, it means that those who are working are more probable users of the library. 1.1 is odds ratio using library versus not using library for those who are working versus those who are not working. 1.1 is odds ratio. You can also find, and that's necessary to comment, that odds ratio could be as low as 0.8 and as big as 1.4. So maybe that there is no difference between those who are working or not, or at least from statistical point of view, as this confidence interval for odds ratio is including 1 and p-value is bigger than 0.05. So there is no possibility to generalize the impact. So still no impact at all. We can differentiate the same phenomenon, so it means working or not, for internet usage. So internet only versus I'm not using internet, I'm not using library at all, yes versus no. You can see that odds ratio here is much bigger, nearly 3 units. And also the confidence interval is totally outside from 1. So at least for differentiation of those who are working or not, if they are using internet or not, I can say, okay, it seems that American population, once again, approximately 15 years ago, it seems there is a difference. And those who are working are more probable or have higher odds to use the internet. And I guess that's quite easy to understand why is it so. As if you were working, you have enough money to buy the internet at home, etc., etc. So it's quite easy to understand these results. And if you take the last one comparison, so it means those who are using internet and library, both of these, and nothing. So once again, our results for these comparisons are at least from statistical point of view promising. 2 is odds ratio and confidence interval 1.6 to 2.5. So at least for the second and the third comparison, we have found some effect. For the first one, this effect wasn't proven, I would say, simply. So that's a result for original binary variable. And the last one, variable that should be maybe applied is some variable that have more categories than only 2. I would use educational categories. I guess there are quite a lot of educational categories, so our output will be maybe slightly complicated, but for the first insight, it would work, I hope so. So I would take this education category here. And you can see that we have quite a lot of educational categories included here. So it means there are some lower educational, so it means our lower and upper high school, then college and graduate school, so it means some university. So these are comparisons, and some what I would call as elementary education coded here as 1 is the reference category. So here it is, and I would expect, at least according to common sense, that those who would have higher education would be maybe library and especially internet using more than those who are less educated. So let's check whether it works. So the case for library. So if we are comparing all categories of higher education with some elementary, once again coded here as 1, I would expect here maybe positive coefficients and maybe odds ratio above 1. But for first 2 categories, it's not present here. And maybe the reason is that some categories are quite sparse. but for college, at least some college and graduate school, you can see that odds ratio are above 1 and are saying the story, okay, higher education means I am maybe more probably using library. For internet usage, I guess nearly the same story can be found. And if you compare odds ratios for library usage and internet usage, for the internet, these values are bigger. So it means that for using the internet, the education is more important predictor than for library usage. And if I go down choosing both of these devices, so it means internet as well as library, nearly the same story as for the internet usage. So these are odds ratios. My recommendation here would be at least for easier interpretation of results, that maybe some categories of education should be merged together and maybe then interpretation would be easier. Another option is that I would take educational category outside from this model as factors, and I would treat this variable with quite long scale as cardinal. So it means as scale. So I would take it as covariate. You can see that in spite of the fact that JAMOVI is showing pictures here, that only scales could be here and only nominal would be here. So it is quite flexible. And if I would apply educational category as cardinal, I would get only one coefficient. And for all of these, so it means, once again, first for library comparison and neither, internet only and neither, and both and neither. So for all of these educational categories, coefficients are positive, and it means that odds ratios for this variable would be above 1. So it means saying the higher the education, the higher odd or higher probability of using library, internet, and both of these devices. So that's a conclusion. And I guess that this is quite enough to say about application of multinomial logistic regression model. The only, I would say, complexity here is that I need to interpret not one set of coefficients, but more sets of coefficients and all these together and find some interpretation through all of these equations. So that's all about application of Polytomous logistic regression in JAMOVI. And the last step that I would like to show you in this first block is that I would open SPSS and we would try to compute the same results here. So before I start SPSS, I would only save these outputs for library. So currently it is saved here. So here it is. So we can close JAMOVI for a minute, at least for this model. And I would be waiting for SPSS. So here it is. I would close this dialog and I would open data file currently. So I guess direct clicking would be the easiest one. So here we are once again, the same data file. So I guess we can go very quickly into computation dialog and into results in SPSS environment. So once again, our dependent variable will be group variable. And for simplicity, I would use once again age as the predictor, then whether somebody is working or not. And then for simplicity, once again, we would apply educational categories. So if you would like to find logistic regression, so you would need to go into analyze regression, and then somewhere in the middle, there is a set of logistic regression starting with binary. Next one model is for Polytomous or multinomial logistic regression, and the next one is for ordinal. So I would go into multinomial logistic regression model. And you can see that dialog here is totally the same as for JAMOVI. So it means dependent variable, you would need to define reference category directly here, then factors and covariates. Only there is reverse order for factors and covariates. So I would take a group grouping variable, which is internet and library. Maybe I can change displaying of technical names. And you can see that by default, the last one category in SPSS is reference one. If you would like to know what is the last one, it would be using both. So if you would like to change it, and in JAMOVI, it was the first category, you can go into reference category, ask for a first one, and that's all. And you can also use another one by custom option. So I would ask for the first one category. And once again, our reference category will be those who are not using internet as well as library. And for simplicity and direct comparison, first predictor would be the age. So I would take age as cover rate. And you can see quite a lot of options here. So I would go quickly through these options. We do not need to discuss about model in detail, but in the same style as we discuss in linear regression, also in logistic regression, you can apply individual predictors, and you can also combine interactions. And I would say the advantage of this dialog, and similar dialog can be found in JAMOVI, you can apply this interaction directly by this dialog. So it's not necessary to multiply individual variables together alone, but you can include interactions here by this simple dialog. So that's the advantage of this procedure in SPSS or JAMOVI. So next one is statistics. You can see that by default, you would get pseudo R-squares values. You would get some model fitting information. So it means values of some test, etc. And you can ask for many other options that are not available in JAMOVI as well. So we would skip it. And there is one more option, and I would once again recommend to use it in JAMOVI. It's not offered, and classification table is present here. So if you would like to find classification table, you can ask it here. Next one, criteria, is quite technical dialogue, so we can skip it. Options are only for some special automated entry of variables, so I guess we can also skip this dialogue. So close it. And then there is quite big amount of options, but it is possible to save into data. In JAMOVI, in Polytomous logistic regression, there is no option for saving. Here you can estimate response probabilities, predicted category probability, and you can also save the whole model in a special XML format. So these are options that are not available in JAMOVI as a whole. So I would skip it, and then there is some special option for bootstrapping, which is especially the dialog for some special cases. There are some small sample sizes and some skewed data. So here we have the first output. So I would click into OK. And you can see that first table is describing number of units for individual variables. So it means here we have a frequency table for dependent variable. Once again, be careful about number of units for individual categories. So here it is automated output. Then we have likelihood ratio test, which is present in the second table. So the value of chi-square, p, and degrees of freedom is present here. It was once again in JAMOVI, the output in the model fit table. Then we have here 3 pseudo R-squares, Cox and Snell, Nagelkerke, and McFadden. So this is nearly the same style. Likelihood ratio test is once again repeated here for individual predictors, so we can skip it. And here is the table with coefficients currently described here as parameter estimates. And here we have individual comparisons, library only and neither, which is not present here in the table, but we know this is a reference category, internet only and neither, both and neither, and intercepts and the impact of the age for individual equations. And you can see that by default, there is coefficients, standard error, test by Wohl's test, degrees of freedom, and p-values. And then automatically exponentiated coefficient, so it means odds ratio and confidence interval for these. If you remember in JAMOVI, we need to ask for this exponentiated coefficient, so it means odds ratio and its confidence interval. Here it is automated output, and one more output which is not present in JAMOVI is classification table, which is describing the overall success for the model. Be careful, if you have more than 2 categories, a rate of success classification is usually quite low one. You can see that overall success here is only 44%. So only in 44%, I am classifying correctly people in 2 categories, neither library only, internet only, and both. But we have only 1 predictor. So that's not a big surprise that the success rate is quite low one. And if I would like to follow previous steps from JAMOVI, I can ask for some more predictors. So if I remember well, we applied variable work as factor. And for simplicity, I would propose to take educational categories as covariate. So it means the last model that we applied in JAMOVI. So if we would apply this model, I guess that classification table will be slightly better. So currently we are at success rate approximately 1/2, 50%. And in the same style, you can find a table with coefficients. Only here you can see that slightly reverse logic in JAMOVI, in comparison with JAMOVI, is applied to binary or nominal independence. The first category, the lowest, is the category this is for which the coefficient is computed, and the reference category are those who are employed. So all these coefficients present here would be totally reverse to previous one. So minuses and pluses will be just opposite. If you would like to change it in SPSS, I guess there is no chance to go into the dialog and change that for work reference category would be 1. So the only chance would be to go back into data matrix and recode variable. So it means reverse the ordering of categories. So this is not maybe very easy step, but you can take it as it is. So in Polytomous logistic regression, it works in SPSS by this style. So that's all about application of Polytomous logistic regression. Here you have some descriptions about SPSS options, which we discussed. Here you have also command syntax for SPSS. And I will only repeat basic information that if your dependent variable is ordinal, there is also a special model which is called ordinal regression or ordinal logistic regression. Here we have one equation, but different thresholds for different comparisons of individual categories. I wouldn't go into details, and once again, if you like to know more, consult the literature. According to my opinion, especially if you would like to apply these models in SPSS, the best chapter can be applied, can be read from Norush's textbook about SPSS procedure companion. So I would skip all these results and outputs are nearly the same: set of coefficients, pseudo R-square, and likelihood ratio test. And last one command that I would like to add today is that quite close techniques to logistic regression are discrimination analysis, which is designed mainly for predictors that are cardinal, and dependent variable should be binary or multinomial, so it means nominal variable with more than 2 categories. And quite close techniques are also so-called log-linear analysis, but for log-linear analysis, you do not distinguish dependent and independent variables. You have only all variables in the same level. And the special sub-model for log-linear analysis is logit analysis, in which there is one dependent variable and a set of independents in the same style as for logistic regression. And a special technique, which is mainly based on graphical outputs, which is very close to logistic regression, is called classification trees, and quite close are also regression trees for cardinal dependent variables. So if you would like to know more, you can consult. Sometimes you can find also the shortage, which is saying CART, which stands for classification and regression trees. So it means 4 letters for this name. So that's all for this first lecture today.